Hello everyone, welcome to Maths Club. So today we will going to do another questions regarding volume of the solid generated by rotating a bounded region by using the cylindrical or shell method. And this time the bounded region will be rotated about a line parallel to y-axis. So the question is, find volume of solid generated by rotating a region bounded between the line y is equal to x and curve y is equal to root x, and this region is rotated about the line x is equal to 2. To identify the region bounded between the line and the curve, first we need the point of intersection between the line and the curve. So to find the point of intersection, we have to solve for x and y between these two equations. So we will equate both the y to get the equation of x. So here the equation become x is equal to root x. To solve this, we have to make square on both the side. That will going to give us x square is equal to x. Now take both the x in the same side, which will gives x square minus x is equal to 0. Then by taking x common, we will get x into x minus 1 is equal to 0. Now you have to equate both of these factors separately equal to 0. So from the factor x minus 1, we will get x minus 1 is equal to 0, which ultimately gives us x is equal to 1. And from the other factor, we will directly get x is equal to 0. Now to find the point of intersections, we need to find out the corresponding values of y. So by putting x is equal to 1 in any one of these two equations, we will going to get y is equal to 1. And by putting x is equal to 0 in any one of these two equations, we will get y is equal to 0. So point of intersection comes from these pairs. One pair is 1 comma 1 and another pair is 0 comma 0. So we can conclude the point of intersection between the curve and the line are 0 0, that is the origin, and another point will be 1 comma 1. Now we have to draw the graph. We have to start with y-axis and x-axis, and then the line y is equal to x and the curve y is equal to root x. Both the region is moving from the point 1 1 to 0 0, and the region bounded between the curve and the line is this region, the shaded part. Now this bounded region will going to rotate about the line x is equal to 2, which is a vertical line. Now like before, to find out the solid of rotation, first you have to take the image of this bounded region about the line of rotation x is equal to 2. So first the image of the line y is equal to x, and then the image of the curve y is equal to root x. Now to complete the solid, first we are going to draw the circle at both ends of the bounded region. So at the top end, this is the circle, and at the bottom end, this is the circle. So this is the around solid we are getting. To make it clear, let's shade the solids. Now we need to find out the volume of the solid by using the cylinder or cell method. Now, according to the cylinder or cell method, we have to draw a cylinder whose axis will be on the axis of rotation, that is x equal to 2, and whose endpoints will be on both the curve y is equal to root x and y is equal to x. So let's draw two circular ends at y is equal to root x and y is equal to x, and then complete the cylinder. Let's shade this also. Now when this cylinder will move from the lowest point, that is on the y-axis, to the highest point, that is on this circular end, which we can denote by y is equal to 1 also, then it will going to cover the entire solid. So to find the volume of the solid, we need to find out the volume of this cylinder. To find the volume of the cylinder, we have to first find the radius of the cylinder and the height of the cylinder. Now radius we can consider is distance between the axis of rotation x is equal to 2 and this line y is equal to x. And this portion, that is the distance of this end point from the y-axis, is also x. So we can say the radius of the cylinder, if we take that as r, is equal to 2 minus x. From this to this is 2 and from here to here it is x. And for the height of the cylinder, height is this portion of the cylinder. So difference of this 2 point is actually the difference of the y from this 2. Y at the top comes from this curve y is equal to root x, and y from the bottom come from the line y is equal to x. So the height is difference of y from both the curve, which we also can write as root x minus x. So let's take a picture without any shaded part of the solid to clearly understand the radius and height of the cylinder. To find the volume of the entire solid, first we need to find out the volume of the cylinder, and then we have to integrate it from one bounded point of the shaded region to another bounded point, that is from origin, that is 0 0, and to the point 1 comma 1. At this point x is equal to 0, and at this point you can consider x is equal to 1. Now the area, that is the curved surface area of the cylinder. Delta A is equal to 2 pi r h. Put the value of r and h in terms of x. So r is 2 minus x and h is root x minus x. Now to find the volume of the cylinder, we need its width also. So here we can consider this portion as the width of the cylinder, and as this is parallel to the x-axis, so we can consider the width as delta x. So finally, volume of cylinder delta V is equal to the curved surface area, that is delta A, multiplied by the width, that is delta x. By substituting the value of the delta A, we will get delta V as 2 pi 2 minus x root x minus x multiplied by delta x. Now this delta V varying from x is equal to 0 to x is equal to 1. So to find out the volume of the entire solid, we need to integrate the volume of the cylinder, that is delta V, from 0 to 1. So volume of the solid V we can write equal to integration 0 to 1 delta of V. We have to replace the delta V and in integrations delta x can be written as dx. So 0 to 1, 2 pi into 2 minus x into root x minus x dx of it. We can take the 2 pi outside the integral, and to integrate it we just need to open up all the brackets. So 2 pi, after opening the bracket we will going to get 2 root x minus 2x minus x root x, that is x to the power 3 by 2 plus x square dx. Now you have to use the basic formula of the integration, that is for x to the power n, which is x to the power n plus 1 upon n plus 1. So after applying the integrations we are going to get this is equal to 2 pi will remain outside. Here there is a root x means x to the power half, n is half here. So 2 into x to the power half plus 1 divided by half plus 1. 2x will going to give you 2x square upon 2 minus x to the power 3 by 2 will going to give 3 by 2 plus 1 divided by 3 by 2 plus 1, and x square will going to give x cube by 3, and the limit is from 0 to 1. Now we will just need to substitute the values of all the limits, the upper limit and lower limit, into the integrated term to find out the final volume of the generated solid. So after substituting the values, the V become 2 pi. At 1 all the x will become 1, so this gives us 4 by 3. Here the 2 will get cancelled to gives us minus 1. Here it will become 2 by 5, and at the end 1 by 3. At 0 every terms become 0. Now simply we need to take the LCM of all the terms to find out the final value of the volume. So here the LCM become 3 into 5, that is 15, and the numerator is 20. 4 into 5 minus 1 gives us 15. Here for the 5, 3 into 2, that is 6, and here for the 3 it is 5. So overall it is your 25 minus 21, that is 4 by 15. The 2 pi into 4 by 15, that is 8 pi by 15. Conclusions here we have the volume of solid so formed is equal to 8 pi divided by 15. So hope you guys understood the procedure. In the next video we are going to find out volume of the solid, but that time so we are going to rotate about a line parallel to the x-axis. So stay tuned for that. That's all for today. Thank you and have a nice day.